Hello guys, this is Orlando Solis. Of course, mine might be out during today, so we have to see how to work everything. I'm making this video so that way you can go ahead and get these. So let's see, a quadrilateral, a closed figure formed by, let me see, line segments. It's not letting me write. I gotta tell it, hey, give me a pen and let me write with a pen piece of. Okay, line segments. So that's any quadrilateral. I mean, that could look something like this. Doesn't necessarily need to be a parallelogram or anything like that, so we have that. Now, here's parallelograms. Parallelograms is a quadrilateral with opposite sides that are congruent or equal. Congruent. Whoa. Congruent. I'm trying to write fast and not wanting to work. So opposite sides are congruent, opposite angles are congruent, a whole bunch of different things is congruent. Also diagonals bisect each other, but you know, that's just some of the stuff that we need to know. Parallelogram, okay, so a rectangle that is rect. Or it has four right angles. Four right angles. So usually we draw that with this right here. We have four right angles. Now, what they don't tell you is that rectangles are also parallelograms because opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and they have all the properties of that. So diagonal is segment joining opposite vertices. Opposite. Now, the reason why they have the opposite right here is because there are certain properties that actually has. Okay, so first right here, the object right here, vertices are, let me see, Q, P, and T, S. Is that R? Q, R, T, S, or S, T. Name of the rectangle is T, S, R, Q. We can say that with a symbol for rectangle. Opposite sides are QT. This is the QT is opposite of PRS, and QR is opposite of TS. I'm not going to write that down. Opposite angles is T and R, of course, and Q and S. Just give me a second. I need to move something. Okay, that takes care of that. Consecutive angles are like QT, and you should know that. And diagonals, well, that's RT and QS. So those two are the diagonals. Okay. Name the diagonals of L, M, and O. Okay, that's B, L, N, and O, M. Okay, so we have these two diagonals. They want us to use the distance formula to go ahead and get the lengths of these diagonals. And, you know, that's something that we just know right here. So LM. So if we do that real quick, I'm just going to use my coordinates. Let me just write these down. I'm going to need them. Okay, so that's negative 1, 2, 3, 4, 5, 6. Negative 6. And that's positive 4. Whoops. Then we have negative 6. And that's going to be negative 3. Positive 3. Positive 4. And then positive 3. Negative 3. So we're going to use that to find our distances right here. I'm going to do that real quick. So the first one, we have, let me see, we're going to do LN. LN, yeah. I don't know why I put LM. Okay, so let's see. That's going to be negative 6 minus 3. Plus, that's going to be 4 minus negative 3. 4 minus negative 3 squared. Okay, so that's going to be positive 7 squared plus a, are you sure that's a 7? Let's see. 1, 2, 3, 4, 5, 6. Yeah, that's 6, and then I'm just making sure something, guys. You know, -3. Yeah, everything's correct. Damn, I hate that. Okay, so I would have gone for something a little bit better to use, but then again, I'm not the one who created this. Square that. All right, so now we have that. So it's basically -9 squared plus 7 squared. So that's going to be square root of, let's see, -9, and then I got to square that, plus 7 squared. And we get 11.4. So I'm going to just write that down, 11.4. So we can check the next one. This is going to be OM. I'm going to do that real quick. So we have the square root, and we're going to start with that, -6 minus 3 again, and that's going to be squared, plus -3 minus 4. It's starting to look a little bit familiar right here, right? So that's going to be -9 squared plus -7 squared. And if you do the math, you get 11.4. So diagonals of rectangles are congruent. They're equal, congruent. Okay, so properties of rectangles. Opposite sides, congruent. Opposite sides are parallel also. We're going to study that, parallel. Opposite sides are congruent. Opposite angles are congruent because they're all right angles. They're all congruent to each other anyway. Consecutive angles, well, they're also congruent. And supplemental. Diagonals bisect each other. For right angles, these are the new parts, and also diagonals are congruent. So this side and this side are congruent, this angle, this angle, this side and this side are congruent. They're also parallel. I'm going to do that with this. These two are going to be congruent. They cut each other into 2 equal parts, and they also have right angles. They're all going to be like that. All right, so that's about it. I mean, this is what you need to know. This is everything. Whoa, why did it go to 2? Son of a bitch, I hate this thing. Sorry, not supposed to cuss. Okay, so quadrilateral is a rectangle. MO, which is this diagonal, and NP, which is the other diagonal, are this and this. So this is going to be 2x minus 8, and this is going to be 23. So 2x minus 8 is equal to 23. Going to add 8. Then I have 2x equal to, let me see, that's going to be 3. That's going to be 31. Divided by 2, well, it's 31 and a half. Or 15.5. And that's all you have to put. And that's about it for that. There has to be something. Okay, so now we have the same thing. We have AC, which is this side right here. Then they give me DP, which is just this part right here. Now, of course, DP is half of AC because they are congruent and it cuts into equal parts. They're bisected. So, AC divided by 2 is equal to what DP is. So we have 4x minus 13 is equal to x plus 7. Oops, I forgot something. I forgot that too. I'm going to multiply both sides by 2. So now this leaves us with 4x minus 13 equal to 2x plus 14. Then subtract 2x from both sides, so that leaves us with 2x. Then I'm going to add 13 to both sides, so that's going to be 27. I don't know what is with these guys giving us numbers that don't give us nice numbers, so 27.5. Or 13.5. That's it. End of story. All right. Okay, so if RSU, let's see, RS and then U, which is this angle, is 3x minus 5, and UST, which is this angle, is 4x plus 4, what is x equal to? Well, these two are going to be complementary because remember, this angle is a right angle. So we have 3x minus 5 plus 4x plus 4 equal to 90. I'm going to solve that really quick. So it's going to be 7x minus 1 equal to 90. Add 1 to both sides, so 91 is equal to 7x. Divide both sides by 7. So let's see, that's going to be 91 divided by 7. This might be a nice number, 13. Ooh, unlucky 13. All right, and that's it for that. That's the end of that story. Okay, so that's property of rectangles. We'll talk about squares in the next video, and I'm going to post them both up.